Hello and welcome to Honors Precalculus, day 21, part 2 of trimester 1. So here's where we left off. We were presented with, or we're now presented with, two different really important triangles. First one on the right we'll look at has angles of 45 and 45, and then a right angle. So one key thing to realize about this is, let's say that this has a side length of A and A, has to be the same. What is this hypotenuse length right here? If we did h, so you might remember it's a squared plus a squared equals h squared, because we know that this squared plus this squared is that squared. Theorem developed by the Babylonians. So we end up with 2a squared is equal to h squared, like that. So then if you take the square root of both sides, you end up with the square root of 2a squared is equal to h. So h is equal to the square root of 2 times the square root of a squared, which is the square root of 2 times a. So what you'll see is this. A is equal to a times the square root of 2. So what you can actually say is h is equal to a times the square root of 2. So whatever length a is, you know the hypotenuse is a times root 2. Now you can do some similar math with an equilateral triangle over here. If you do similar math with an equilateral triangle, you know that 60 degrees and 60 degrees, and this whole thing is 60, so this is 30 degrees. What you can do is, if the side length is, let's say, A on this side and A over here, the base right here is going to be 1/2 A. So if we want to know what the height is here, what we can do is, let's call that, let's say, we'll call that y, just to give it something else. You know that 1/2 a squared plus y squared is equal to the hypotenuse squared, which is a right there. So you have a squared over 4 plus y squared is equal to a squared. So you end up with y squared is equal to, you subtract 1/4 a squared, you end up with 3a squared over 4. And when you take the square root of this, you end up with y is equal to, if you take the square root of this and simplify it, you end up with a root 3 over 2. So the height of this is a root 3 over 2. So then what you can do is end up with, what we wrote there is, if this was a, this base would be 1/2 a, and this height would be a times root 3 over 2. We can multiply them all by 2 you can keep the same ratio, multiply all of these by 2. So you end up with what you need to memorize, which is, we'll double each of these. So this turns into 2a, this turns into a root 3, and this turns into a. So what this means is, if you have the shorter one is a, the hypotenuse is 2, and this is a root 3, when you have the angles 60 here and 30 degrees here. Why is this helpful? Well, if I ask you for the sine of 30 degrees, that would be the sine of this angle. Sine is equal to the opposite over hypotenuse. The opposite side is going to be a, and the hypotenuse is 2. Sorry, this is 2a. I forgot the a right there, over 2a. Well, the a's cancel, so you end up with a sine of 30 degrees is 1/2. Well, sine of pi over 4, that's 45 degrees. So that's this angle right here. Sine, again, is opposite over hypotenuse. So the opposite is a, and the hypotenuse is a root 2. The a's cancel again, and you're left with 1 over root 2. Now, you're going to see this written a little differently. I'll do the work up here so you have more space. 1 over root 2, you can multiply by root 2 over root 2, and you end up with root 2 over 2. This is the same thing as root 2 over 2. That's a common thing you'll see, but they're the same. Sine of 60 degrees is going to be looking at this angle right here. And again, sine of 60 degrees, remember, it's an opposite over hypotenuse. When you do opposite over hypotenuse, the opposite side is a root 3, and then the hypotenuse is still going to be 2a, like this. So when you do this out, they cancel, and you're left with root 3 over 2. So what you just have to remember here each time is SOHCAHTOA. So SOHCAHTOA. So sine is opposite over hypotenuse, adjacent is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you do the cosine of 30 degrees, so here's our 30 degrees, Cosine is adjacent over hypotenuse. So that's going to be a root 3 over the hypotenuse, which is, again, 2a. They cancel, and you're left with root 3 over 2. Cosine of 45 degrees is adjacent over hypotenuse. So that's going to be a over a root 2, which is 1 over root 2, which you know is equal to root 2 over 2. Pi over 3, cosine of pi over 3, that's the same as cosine of 60 degrees, if it helps you thinking of it like that. 60 degrees is the same thing as pi over 3 radians. So that's going to be adjacent. So that's going to be a over the hypotenuse, which is 2a, and that just cancels to be 1/2. So when you do these out, you get the tangent, and really pi over 6 right here, pi over 6 is 30 degrees. Tangent is opposite over adjacent. So 30 degrees right here, 30 degrees, it's opposite. Opposite is a over adjacent, which is a root 3, and you get 1 over root 3. Similar to 1 over root 2, 1 over root 3, you can multiply by root 3 over root 3, and that's going to be root 3 over 3. Same thing. Tangent of 45 is going to be a over a, because it's adjacent over opposite over adjacent, so that's 1. And then tangent of 60, here's 60. It's the, remember, opposite over adjacent, so opposite, so it's going to be equals a root 3 over the adjacent, which is going to be a, so that's just equal to root 3. So memorize these, fill them in, the a's cancel. So in this question, it says find the point on the unit circle, so that's important, unit circle, exactly, and then 3 decimal approximation that the terminal ray of 135 degrees angle goes through. So if this was a unit circle, the scale is not going to be accurate. It's going up to, these are 0.8, negative 0.6, negative 0.4. So again, this is 1 right here. So this is y equals 1. 135 degrees you get, this is the initial ray, and then you go 135 degrees. Well, if you go to here, that's 90. And if you go to here, that's 180. 135 degrees is going to be 45 degrees past 90. So that's actually going to go back at this angle right here. So 135 degrees is this right here, 135 degrees. So if we want this coordinate, that's what it's asking you for. Find the point on the unit circle right there. You now know that the whole thing is 180. So what does that mean? It means this right here is 45 degrees. So we're looking at this blue triangle right here, where it's 45 degrees. So what that means is what we might remember from earlier, the coordinates there are cosine of theta, comma, sine of theta. And in this case, theta is going to be equal to 135 degrees because you go all the way from here to here, 135 degrees. So what do you end up with? Look at this triangle right here. What is the x value here? Well, you're going backwards from 0, so it's going to be negative. This turns out to be negative root 2 over 2. And what's the height here? Well, that's up. It's positive. And since this is 45 and 45, the base and height of this triangle are the same. It's going to be root 2 over 2 again. And if you use your calculator, you end up with negative 707, comma, 707. These go on forever because they're irrational, but you're going to recognize 707 a whole lot. Now, what about 315? 315, you're going to keep on going until you get to here. This would be your terminal one right here. And it's the same thing, but instead you're going to have 45, 45 right here. 45 degrees and 45 degrees. And remember, the x-coordinate is going to be this distance. Well, that one is going to be root 2 over 2, but then you're going down to this point, so it's negative root 2 over 2. So the decimals would be 0.707, comma, negative 0.707. And you know that because of the triangles you get here. This triangle right here, it's black now, is going to be the 45, 45, 90. And then this blue triangle over here that we did originally for the first one is 45, 45, 90. So when you evaluate these, it's really great, and you should draw, especially at the beginning, where do these angles occur. So 135 degrees occurs like this, because this is 135 degrees, 135. So what triangle do you have right here? You have this triangle right here, and that's going to be 45 and 45 degrees. And you do it on a unit circle, so the hypotenuse is 1. So you therefore know that this height is root 2 over 2, and it goes back, so it's negative root 2 over 2. So the sine is the y value. So the y value, the height, is going to be root 2 over 2. Cosine of this next angle, 225, where's 225? Well, that's going to be all the way to 180 to there, so you go to 45 more, it's to here. So what triangle is this right here? Well, that's again 45, 45, 90. And cosine is going to be the x value here, the green, so that's going to be negative root 2 over 2. Sine of 210 is going to be 180 degrees plus 30. So you have the 30 degrees right here. So this is the triangle you have. You have this blue triangle, so that's going to be 60. So the long side of the long base here, that's the x value. This is 1. This is negative a half. This is going to be negative root 3 over 2. So you need the x value. It's going to be negative, sorry, excuse me, the y value. The y value is negative 1/2, which I kind of gave away the next one here. If not the next one, but if I asked you this, what would be the cosine of 210 degrees? Cosine of 200 adjacent over hypotenuse would be negative root 3 over 2, the x value. So if you set all these up, you're just going to have that 45, 45, 90 or 30, 60, 90 triangle show up. So 330 degrees, 330 degrees, you go all the way around to here, and you end up with 30 degrees left right here. So that's 30 degrees, and this is 60. So remember, the longer side, the x value right there would be root 3 over 2, and the shorter one going down is negative a half. Well, cosine is the x value, so in this case it's going to be root 3 over 2. So what about 405 degrees? Well, you're going to go past it. So what that means is 360 all the way around. So if you subtract 360 from this, you go 45 more, you're going to end up with this angle right here, which is just 45 degrees, because 360 plus 45 is 405. So you're back to 45 degrees. So you have 45, 45, 90. The hypotenuse is 1. So this height is root 2 over 2, and the base is root 2 over 2. Sine, you want the y value, so it's going to be root 2 over 2. Now you could go backwards. So instead of going counterclockwise, we're going to go clockwise. So when you have cosine of negative 405 degrees, cosine of negative 400 degrees, instead of going counterclockwise, which is the forward way, I know it's a little weird, you're going to go this way, and you're going to end up 45 degrees down. So this is the triangle you have right here, 45, 45. So we know that it's the x value of this. So the x value of that is just going to be, as we know, root 2 over 2. Many of these values get repeated over and over and over again. So do a few more. Cosine of 390, you're going to go around to 360 and then go 30 degrees more. So you have a 30 degree 60. Cosine is the x value again. The long side of a 30, 60, 90 triangle is root 3 over 2 when the hypotenuse is 1. So the answer here is root 3 over 2. And then 765, you're just going to go around twice. So you have 360 and then 720, and then you go 45 degrees more to get to 765. So you end up with 45, 45, and again, you're looking for the y value because it's sine this time. So it's going to be root 3 over 2. So you can go around multiple times, and we know that theoretically makes sense because these functions are cyclical. So here are some more practice problems for you. So you're going to find the point where the terminal ray of the following angles in standard position intersect the unit circle. So it's a circle of radius 1. So 40 degrees here. If it's 40 degrees, that's not a triangle we know. So the point right there when it's 40 degrees, remember, is going to be cosine of 40, comma, sine of 40. Those are trig values that you need to use your calculator for. So when you do that, you end up with 0.766 and 0.643. These are in degrees, which is super important because your calculator can be in both modes. So when you do these, you can use your calculator, Keep in mind that these are degrees, but because there's no degree mark, that is in radians. So you have to turn your calculator onto radians. Use your calculators for these. Be very, very careful and be very deliberate.